Hey guys, this is lesson 1.4 of transformations, and today our focus is dilations. So some key vocabulary for us. So pretty much a dilation is just taking a shape and making it either larger or smaller. The biggest thing is that these two shapes are quote unquote similar to each other. And we don't just mean like arbitrarily similar, we mean like mathematically similar, which means that corresponding sides are proportional and they're parallel to each other. And we'll talk definitely a lot more about corresponding sides. But yeah, so corresponding sides, a little bit more with like the sides that kind of go along with the other sides, which it'll be easier to see once we have some graphs, so no worries. Now, a dilation has a scale factor, and that scale factor is some sort of number, and that represents the ratio of the lengths of those like corresponding sides that we were talking about. So like pretty much comparing the big and the small, or the original and the new one. Now for the scale factor, even though it's a number, sometimes we use the letter K as a symbol. And again, like I said, our dilation could get larger, which we call an enlargement, or it could get smaller, which is a reduction. Excuse me. So for an enlargement, if we're doing an enlargement, that means the scale factor is larger than 1. If it's a reduction, that scale factor, that number, is between 0 and 1. Now, if it's actually equal to 1, nothing has happened. So again, larger than 1, enlargement, between 0 and 1, reduction. So let's look at how to write a dilation. Just like for our other transformations, we have some rules and also like the function and the wording. So for us to recognize a dilation, we need to look for that number that's being multiplied in front of x and y. Remember that number is called a coefficient. So for example, we have a rule here with the 1/2, and that's being multiplied in front of x, just like 1/2 is being multiplied in front of y. If I do my function, instead of doing like that T for translation, now we're doing a D. Technically it can be lowercase or uppercase, either way. So notice right here, this 3, that means it's going to be our scale factor. So we know that for this one, our scale factor, or K, is equal to 3. So think about it. If K is equal to 3, if my scale factor is 3, is this going to be an enlargement or a reduction? Well, remember that it is greater than 1. So that means it's going to be an enlargement. And again, that's because 3 is greater than 1. So let's write the rule. So we know we have x, and we know we have y. And again, our scale factor is always going to be multiplied in front. So 3x, 3y. All right, let's look at another one. So we have an enlargement. Scale factor is 4. So k is equal to 4. All right, so let's write our rule. So 4x, 4y. Because again, scale factor is being multiplied. So again, we could do lowercase, or you sometimes see it as uppercase. So like D, and then 4. Remember that a 4 needs to be written smaller and at the bottom. All right, so let's look at this rule. So I've got 3 over 2. Okay, so I know D will make this one lowercase. 3 over 2 is my scale factor. So we know K over here is 3 over 2. But careful, even though it's a fraction, because remember we could have like K being smaller than 1 or K being larger than 1. Just because it's a fraction doesn't mean it's smaller than 1. It's 3 over 2. It's an improper fraction. So it would be like 1 and 1/2 or like 1.5. And that's larger than 1. So this is still an enlargement. And just to kind of like note up here, we had a scale factor of 1/2 or like 0.5. And so remember, 0.5 would be in between 0 and 1. So that's why that would be a reduction. All right, let's take a look at some calculations. So we need to be able to actually calculate the new coordinate point based off the scale factor. And then we also need to be able to reverse and find the scale factor by the coordinate points. So let's take a look. So for this first one, we have the pre-image and the image, and we need to figure out what k, aka the scale factor, is. So we're going to use this formula right here. So we're going to take the new and divide it by the old. So new one would be our image, and the old one would be our pre-image. So if I take -3 and divide by -1, well, a negative divided by negative is a positive, and 3 divided by 1 is 3. So we know that our scale factor here, k, is equal to 3. So is it an enlargement or a reduction? And how do we know? Well, we should know that it's an enlargement. And that's because our scale factor, or k, is greater than 1. So our rule here, and you can see like this would be like our original or our pre, and this would be our like new or our image. So we can just write the rule in general. So that would be 3x, 3y. And again, this is a coordinate point, so it needs parentheses. All right, let's look at the next one. So next one, we have the old, and we know what the rule is. So remember, we need to apply the rule. So we're pretty much like substituting 24 for x. So we know like this is going to be 1/2 of our x is 24. And then 1/2, and our y is -8. So like literally you can substitute. So what's half of 24? That would be 12. All right, just below here, 12. And half of -8 is -4. So this would be my image. We know that our scale factor, our k, was 1/2. And it should be a reduction. And it's a reduction because k is between 0 and 1, because obviously 1/2 would be in between. All right, pause the video and then try the next two on your own. Hit play and then you can check your work. All right, let's look at this one. So notice how we have the new, and we need to go backwards. So we have the scale factor here. So if my scale factor is a 2, that means it got enlarged. So we got bigger because k is greater than 1. And our rule would have been 2x, 2y. Now, but remember, we have to go in reverse because this is our new one. The 4, 6 are new, and we've got to go in reverse. So if normally we would multiply, the inverse of multiplication is division. So what's 4 divided by 2 and 6 divided by 2? So that would mean 2 and 3. All right, let's go with this last one here. We've got 1/3 as our k value, so we know to do 1/3 x, 1/3 y, and again, that's a coordinate point, so parentheses. This is a reduction, and this is a reduction because k is between, it's an abbreviation for between 0 and 1. All right, so now we need to actually do our scale factor times our original. So we're going to take 4 times 1/3, and then we also have -9 times 1/3. Now, if we're just remembering fractions, put 4 over 1, multiply straight across, that would be 4 over 3. Over 1, that would be -9 over 3, which we can simplify because -9 divided by 3 would be -3. All right. So just doing some calculations there. Let's look at some graphs just to make sure that we understand graphs going on here. All right, so we need to know what the coordinates would be if the scale factor is 2.5. So looking at 2.5, so 2.5, we know that this is going to get larger. And we need to know the current coordinates. So our we've got G here, and that looks like it's at 3, -1. S here is at 3, looks like -3. And Q is at 1, -3. All right. Remember that we have a scale factor, so everything gets times 2.5. And we need our image. So literally, you can take a calculator, and we just need to do our calculations. So 3 times 2.5 would be 7.5. And then -2.5. So it would be for G prime. For S prime, we would have the same thing, 7.5, comma, and then this one would be -7.5 as well. And then Q would be 2.5, and then -7.5. All right. Let's see. I think this is actually going to pop off our graph a little bit, but you can get the idea. So we would be doing 1, 2, 3, 4, 5, 6, 7, someplace over here. And then, down 2.5, 1, 2, and kind of a half somewhere over here. And then, let's see here, 1, 2, 3, 4, 5, 6, 7. So again, someplace over here. Oh, there we go. And then last one would have been 2.5, and then someplace down over here. So again, kind of came off our graph a little bit. That's okay. But we had done Q prime, S prime, and G prime. And notice when we're talking about corresponding sides, so right here, Q to G, this corresponds with this Q to G. And so these are going to be parallel. So again, the idea that the corresponding sides are parallel, and that's our little symbol for parallel. Because remember, parallel meaning that they would not touch. We also have GS and GS over here. Those would be parallel as well, those two sets. And then QS and QS, those would be parallel to themselves. All right, one last one. So we need to figure out the scale value and what it means. So scale value. So, excuse me, that should not be scale value. That should be scale factor. Whoops, that's okay. All right, so a scale factor. So if you remember from before, our little formulas here, we said new divided by the old. So new divided by old. So how do I know which is which? Well, hopefully you saw little tick marks or not tick marks. Now, we don't have to do all three sides, but we can do all three sides just to double check that we've got this correct. So let's see here. And remember, K is for scale factor. All right, so our new one is, let's use this 10. And our old one is this 4. Because again, we got to make sure that this side corresponds with this side. So P to R and P to R. So if we do that, then we know 10 divided by 4 would be 5 over 2. And that would be our scale factor. And that's an improper fraction. 2 goes into 5 twice. and we would still have a 1/2 left over, so that would be 2.5. So if our scale factor is 2.5, that means that the pre-image grew 2.5 times. All right, so those are dilations. We'll practice some more at class.